Alright guys, in this first video today we're going to be simplifying square roots. So I'm going to go through 6 examples. These are the ones in my class worksheet. So hopefully you're able to get the first couple without any help, and so you'll be able to go on. So here we go. Here's question number 1. We're going to go with the square root of 108. So the way that we learned in class to do this, there's a couple of different ways. If you can identify what perfect squares go into 108 right away, then you can work with it straight from that. You can take out the perfect squares, the square roots. We're trying to square root anything that we can possibly square root. Now, if you don't know what goes into 108, then you just do this. You say, well, I know that 108 is even. That means 2 goes into it. 2 into 108 is 54. Now 54 is a number I can work with. 54 is 9 times 6. 9 is 3 times 3. And 6 is 3 times 2. And so I can rewrite this as being the square root of 2 times 3 times 3 times 3 times 2. So I've got those 3. 2 times 3 times 3 times 3 times 2. There we go. And so now what I'm going to do, and I'm going to match up the pairs. By matching up the pairs, I'm going to get perfect squares. You'll note that if I put 2 times 2 together, then I have 4. Now notice I haven't taken any square roots, therefore everything is still under the square root. I've got 3 times 3, which is 9, and then there's still a 3 that's left over. Now at this point, what's going on in my head is I'm thinking, okay, well this is the same thing as the square root of 4 times the square root of 9 times the square root of 3. Well, I can take the square root of 4, that's 2. I can take the square root of 9, that's 3. I can't take the square root of 3, so that's going to stay the same. 2 times 3 is 6. The answer to this one is 6 root 3. Let's look at another one. Here we go. Number 2. This is the square root of 98. Again, maybe you know, maybe you don't. So let's go ahead and work straight with this. I know 98 is even, so 2 goes into 98. That leaves me with 2 into 9, 4 times remainder of 1, 18, that's 49. 49 just happens to be 7 times 7, which means the square root of 98 is the same thing as 2 times 7 times 7, which means it's the same thing as the square root of 2 times 49, because 7 and 7 are a pair. Now, you could have gotten that from this point right here if you had recognized 49 as being a perfect square. If you didn't, it's all right. We'll do it here. So now I've got the square root of 2 times the square root of 49. I'm doing the same thing as over here. I'm just not going to write it out every single time. I will one more time this time. So the square root of 2 times the square root of 49. I can't take the square root of 2, therefore it stays as the square root of 2. I can take the square root of 49, that's 7. So I'm either going to have times 7 here. I like to have the square root at the end. That's the more formal way of doing it. So it's going to be 7 root 2. That's the answer to question number 2. Let's go on to number 3. Number 3 is the square root of 56. So 56 is 7 times 8. 8 is 4 times 2, and 4 is 2 times 2. So this is the square root of 7 times 2 times 2 times 2. Right? 7, 2, 2, 2. Only the things from the ends of the branches. The 4 is in the middle, so I don't count that one. The 4 is right here, included in those 2's. This 8 is right here, and that 4 and that 2, so I don't need that one either. Just the things on the ends of the branches. So I do 7 times 2 times 2 times 2, which is the same thing as the square root of 7 times, I'm going to put the pair together, 7 times 4 times 2. Again, this is the root of 7 times the root of 4 times the root of 2. The only thing I can take the square root of is the 4. So I'm going to take the square root of the 4. The square root of 4 is 2. Everything else has to stay inside the square root, which is the 7 and the 2. 7 times 2 is 14. That would be that answer. All right, let's go on. Let's do another one. Number 4. This is the square root of 150. Now, if you don't choose the same numbers as I do right off the bat, it's fine. This will work no matter what, because you're breaking it up to its prime factors, which you'll get to that anyway. So 150, I see that and I say, okay, well that's 15 times 10. Maybe you looked at it and said 2 and 75. Maybe you looked at it and you said 6 and 25. I don't know. Maybe you looked at it and said 3 and 50. It doesn't matter. In the end, when you factor this out, 5 times 3, 2 times 5, it's going to give you the same thing. So this will be the square root of 5 times 3 times 2 times 5. So I've got a pair of 5s there, which is 25. So this is the square root of 25 times 3 times 2. I can take the square root of the 25. Square root of 25 is 5. I cannot take the square root of the 3 or the square root of the 2, which means I'm left with 3 times 2, which is 6. There you go. On to the next one. Let's do number 5. So, moving on to number 5. We've got square root of 54. 54 is 9 times 6. 9 is 3 times 3. 6 is 3 times 2. And so this is equal to the square root of 3 times 3 times 3 times 2. I'm looking for the pairs because they'll make a perfect square. So the square root of 9, with the other 3 and the other 2 don't have pairs. Again, the square root of 9 is 3. The square root of 3 can't do. Square root of 2 I can't do, so they have to stay inside. 3 times 2 is 6. There we go. And the last one for this set, number 6, the square root of 500. I look at that and I see 5 and 100. And 100 is 10 times 10. Now you could keep going. You could break the 10 up to the 2 and the 5, but I see a pair of 10s here. So I'm going to write this as the square root of 5 times 10 times 10, because then I have 5 times 100. I can't take the square root of the 5, so it needs to stay as square root of 5, but I can take the square root of 100 because that's 10 times 10. So the 10 goes out, 10 root 5. There you go. That's simplifying simple radicals.